Hello students, good morning. So today we are going to start with the next topic, that is nuclei. So today in this lesson we are going to discuss the nuclear force, the types of the nuclear processes, nuclear energy, binding energy, then Einstein's mass energy relation. And here in this lesson we are going to discuss the types of, means based on the mass number and atomic number. Here the types of the different atoms we are going to discuss. Okay, so first let us see, before going to start with the questions, let us discuss the synopsis. As you know that, so ನಿನ್ನೆ ಕ್ಲಾಸ್ ಅಲ್ಲಿ atoms ಅಲ್ಲಿ ನಾವು ಕೆಲವೊಂದು ಪಾರ್ಟ್ ಅನ್ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ ಇದರಲ್ಲಿ. ಸೊ ಏನ್ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ, we know that what do you mean by the atom now. So atom ಅಂತಂದ್ರೇನು, it is the smallest particle of the matter, it is called as atom. Smallest particle of the matter is called as atom, and whatever the atom is there, it consists of, so in the atom the positive charges are there, in the atom we have the negative charges. The positive charges are called as the protons and the negative charges are called as the electrons. Okay, so the atom consisting of three fundamental or the three elemental particles. So what are the three elemental particles here? The three elemental particles are known as protons, neutrons and the electrons. Yes, so what do you mean by protons? The positively charged body or the particles are called as protons. The negatively charged bodies or the particles are called as electrons. What do you mean by neutrons here? Neutrons are not having any charge here. Okay, here what do you mean by nucleus? The positively charged particles are concentrated at the center. So this heavy part of the atom, this is called as what? That is heavy positively denser part of the atom is called as nucleus. That is called as the nucleus here. Okay, so here in this nucleus, whatever the volume of the nucleus is there, it is 10 raised to minus 12 times that of the volume of the atom anta ಹೇಳ್ತಾರೆ ಹೌದಾ. So this is regarding the atom and the nucleus and the fundamental particles of the atom here. Then next here we have some of the definitions, like we are going to define what do you mean by atomic number. We are going to define atomic number. So what is atomic number? This atomic number is denoted by the letter Z. This atomic number is defined as the number of protons. The number of protons are called as atomic number. Okay. Next we are going to define the mass number. So what do you mean by mass number? Yes. So mass number is denoted by the letter A. This mass number is defined as it is the number of protons plus number of neutrons. Number of protons plus number of neutrons are called as what? Mass number here. Okay, atomic number is denoted by the letter Z. Mass number is denoted by A. The number of protons is called as atomic number. The number of protons plus neutrons, it is called as the mass number. Then here the representation of the element. So suppose X is any of the element, it is represented with the atomic number and the mass number. So it is represented by ZA. So where is A is mass number, Z is the atomic number. Okay, so ee lesson alli the based on mass number ಮತ್ತೆ atomic number ಮೇಲೆ ನಾವು ಇಲ್ಲಿ ಕೆಲವೊಂದು types ಅನ್ನ ನೋಡ್ತೀವಿ. So what are those different types here? The first one is called as, okay, the first one is isobars. So what do you mean by isobars here? In the isobars, the number of protons will be same. The number of protons will be same, but the number of, or you can say that Z number will be same and A number will be different. So if I say Z is same, A is different, it is called as isobar. It is called as isobars. Okay. Then next we are going to define, sorry, this is isotopes. These are isotopes. Then we have isobars. So we have first type, that is called as the isotopes. In the isotopes, The number of protons will be, or the atomic number will be same, but different mass numbers will be there. In case of the isobars, here the same mass number will be there. Same mass number will be there, but different atomic numbers will be there. And we have isotones here. So what do you mean by isotones? Here, the nuclei having the same number of neutrons. But different number of atomic number. This is called as what? Isotones, isotopes, isobars, and the isotones. Okay, so these are the main three types. So in chemistry ಏನ್ ಮಾಡ್ತೀರಾ ನೀವೆಲ್ಲಿ isomers ಅಂತ ಕೂಡ ಕರೀತೀರಾ, ಹೌದಾ? So there you have again different types, but here we are going to define mainly isotopes, isobars, and the isotones. Okay, then next. So the next concept, that is size of the nucleus. So what is the size of the nucleus? Here, whatever the volume of the nucleus is there, it is directly proportional to the mass number. We can say. Okay. So therefore, volume of the nucleus can be substituted as 4/3 pi r cube, which is directly proportional to the mass number. So 4/3 pi is constant iddaga naan idanna ಏನಂತ ಬರಿಬಹುದು? I'll take, instead of small r, ನಾನು capital R ಅಂತ ತಗೋತೀನಿ. So it is R is equal to R naught a to the power 1/3. Okay. So where R naught is constant, and its value is 1.2 into 10 raised to minus 15 meter. 1.2 into 10 raised to minus 15 meter. Okay. So this is what the size of the nucleus, and the radius of the nucleus is given by R is equal to R naught a raised to 1/3, where a is the mass number, R naught is constant, and the value is 1.2 into 10 raised to minus 15 meter. Okay, this is regarding the size of the nucleus. Then next we have here nuclear density. So the nuclear density is defined as what? Density ಹೇಗೆ define ಮಾಡ್ತೀವಿ? It is nothing but what? Mass divided by volume is called as density here. Okay, the mass of the nucleus can be substituted, and the volume of the nucleus can be substituted here. So the mass of the nucleus, I'll write it as, that is the mass number into 1 AMU, atomic mass unit, divided by volume of the nucleus is 4/3 pi r cube. Yes, so now illen a ide, nan adanna as it is idtini. So 1 AMU in terms of kg I'll substitute. It is 1.66 into 10 raised to minus 27 agutte. Then 4/3 pi r cube is there. So ನಾನು ಈಗಷ್ಟೇ ನಿಮಗೆ radius value ಅನ್ನ ಹೇಳಿದ್ದೆ, ಅದೇನ್ ಬಂದಿತ್ತು, that is R naught into a raised to 1/3. So instead of that, I'll take it as R naught cube into a, because R cube is there. Therefore, if you simplify that, it will be R naught cube raised to a. So here the density of the nucleus is given by, here all are the constant values. If I substitute here, the value comes out to be 2.29 into 10 raised to 17 kg per meter cube. 17 kg per meter cube. So this is the density of the nucleus. So as you can see that the value, value is 10 to the power 17 irodrinda, we can say that the nucleus is highly compact anta ಹೇಳ್ತಾರೆ. ಏನಂತ ಹೇಳ್ಬೋದು ನಾವಿಲ್ಲಿ? nucleus highly compact ಅಂತಂದ್ರೆ very small it is, but it is consisting of more positive charge. Yes. Then next we have the mass defect. So what is mass defect here? Mass defect anna ನಾವು delta m ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತೀವಿ. ನಮಗೆ ಈಗಾಗಲೇ ಗೊತ್ತಿದೆ, that is atom consists of protons, neutrons and the electrons. So ಇದೇನ್ individual particle mass ಇರುತ್ತೆ, if I calculate these individual particle mass and the mass of the atom, there is a slight difference in this atom, that is the mass here. Mass of the atom igu ಮತ್ತೆ ಅದು ಏನೇನ್ constituents of the atom is there, ಅದ್ರದ್ದು mass ಗೆ difference ಬರುತ್ತೆ. So that small difference in the masses of the atom and the constituents of the atom, that is called as mass defect. So this mass defect can be calculated as delta M is equal to ZMP plus M minus N into Mn minus capital M. Capital M is the mass of the atom, okay, or the mass of the nucleus we can say. Then the remaining is constituent masses, constituents of the nucleus, that mass it is. Yes, so energy of the nucleus is calculated as, according to Einstein's relation, Z is equal to mc square anta barutte. So whatever the m value is there, iden value ideyalla idanna illi substitute ಮಾಡಿ, then c square I'll write as it is. So idrinda now energy of the nucleus can be calculated. So here we define one more concept, that is called as the binding energy. Binding energy antandrenu, we know that the nucleus consists of the protons and the neutrons. Howda? So these protons and neutrons together, what it is called, students? Protons and neutrons both together, what it is called? Yes, protons and neutrons together, it is called as enanta karitare? Akash, Abhishek, Gautami, Harshita. Yes, what is the answer? Nucleons. Yes, Rakshita, that is, it is called as nucleons here. Here the protons and the neutrons together, it is called as nucleons. So these nucleons, to hold these nucleons within the nucleus, that is, whatever these nucleons are there, idanna hold ಮಾಡಬೇಕಾದ್ರೆ ಹಿಡಿದಿಡಬೇಕಾದ್ರೆ ನಮಗೆ ಕೆಲವೊಂದು external energy ಬರುತ್ತೆ. So that energy is called as binding energy. Okay, that energy is called as the energy required to hold the nucleons within the nucleus is called as binding energy. So here we have the binding energy per nucleon. So the binding energy per nucleon, the formula is given by this binding energy divided by A. Okay, where A is the mass number. Idinda ನಾವು binding energy per nucleon anna calculate ಮಾಡಬಹುದು. Then we have the nuclear force. So what do you mean by nuclear force here? That is the force within the nucleus of the atom, or the within the nucleus, whatever the forces are there to hold the nucleons, that force is called as nuclear forces. These nuclear forces are short range forces. They are short range forces. They are charge independent. These forces are charge independent. And these nuclear forces are strongest force in the nature. So there are four fundamental forces are there in the nature. That is gravitational force, electrostatic force, then the electrostatic force, strong nuclear force, and the weak nuclear force. In all the four fundamental forces, among all the four fundamental forces, this nuclear force is the strongest force in nature. Can anyone tell me which is the weakest force in nature?
Gravitational force.
Yes, it is a gravitational force, right? Okay, so last concept we will discuss, that is, here we have the two processes called as nuclear fission and nuclear fusion. So the nuclear fission and the nuclear fusion, as the term indicates, fission antandre enagatte, fission andre it is splitting. Fusion is what? Fusion is the combining. So here the two light nuclei combine together to give the heavy nucleus, that is called as fusion reaction. What is fission reaction? That is the heavy nucleus splits into its smaller nuclei. It's a smaller nuclei, that is called as fission here. That is called as fission. Yes, the strongest forces, this only strong, that is a nuclear force. Strong nuclear force is the strongest force in the nature. Nandish. Okay, then the last one more point is there, that is regarding the alpha decay, gamma decay, and the beta decay. Just we will see the highlights here. We will go for the question answers. So we have three processes or the three decays called as alpha decay, beta decay, and the gamma decay. Okay, so here what happens, whatever the radioactive substances there, if it is kept, the radioactive substances, what it will do, it will emit some radiation. It will emit some radiation. This is called as what? Radioactive phenomena. This is called as radioactive phenomena. So the nucleus, heavy nucleus will exhibit this phenomena, radioactivity. So this radioactivity, first it was discovered by Becquerel. First it was discovered by Becquerel. Then next, Madame Curie. They all will develop the radioactivity of the substance. So during this radioactivity, here what happens? There is a decay process takes place. So during that, three radiations we will consider, that is alpha decay, beta decay, and the gamma decay. So during the alpha decay process, here what happens? That is, suppose if I consider the example X as ZA, it is any one element. Okay. So when the alpha decay takes place, the mass number decreases by 4 and the atomic number decreases by 2, So this is called as what? Alpha decay. So along with this, it will give the helium nucleus plus the energy. Then during the beta decay. So during beta decay, what happens? Here, whatever the element is there, so the beta decay process takes place. So beta decay, there are two beta decays are there. That is beta plus decay and beta minus decay. So during the beta plus decay, the proton gets converted into N and it will release the positron. If you consider along with the element, here the mass number remains as it is and the atomic number decreases by 1. This is beta plus decay. So during beta minus decay, here it will be Z plus 1 and here it will be A. Atomic number remains as it is. The mass number remains as it is. Atomic number increases by 1. This is beta minus decay. Okay. So here this is proton gets converted into neutron plus with the liberation of electron. So E plus another positron anta karitare. Positron. Okay. Then the last one, gamma decay. So during gamma decay, what happens? The gamma decay, it is nothing but what? From the excited state, the unstable nuclei will come to ground state by the elimination of some energy. That energy is denoted as E is equal to h nu. So this is the gamma decay. Whatever the radiation it is giving, that is a gamma decay. Yes. So now we will go for the questions. So previous questions again, like yesterday's class, at the end we will discuss. So you people got the previous year questions. Did you get it? Atoms and nuclei. It is shared with you or no? Still you did not got. Okay, I have forwarded it to sir. Sir may send you later. Okay. Nandish is saying they got it. Okay, just check whether you received it or no. So atoms and nuclei, the previous year questions I have forwarded. The wave optics, ray optics, by evening I'll forward it. Okay. So I'll ask sir once again. So now at the end we will see this nuclei lesson again based on this 2 marks questions you may get in the Karnataka CET. So here is our first question, that is, the neutron was discovered by whom? Marie Curie, Pierre Curie, Rutherford, James Chadwick. Yes. Yes, Harshita, Lohit, they are saying it is option D. That is James Chadwick. Yes, correct it is. Yes, very good. So the discovery of the neutron was given by James Chadwick. It is a right answer. Okay, then the next question. So here is our next question. The magnetic moment of a revolving electron around the nucleus varies with the principal quantum number as which of the following? So I'll repeat. The magnetic moment of a revolving electron varies with the principal quantum number. Or really magnetic moment ಗೆ ಮತ್ತೆ principal quantum number ಗೆ relation. First option, usually we here is known as mu. So mu is proportional to the principal quantum number n. It is inversely proportional. It is square of the principal quantum number, or it is inversely square of that. Yes. Girish Kumar. Correct, it is. Option A is right here. Option A is right. That is, it is directly proportional like that. So the principal quantum number is directly proportional to the your magnetic moment. Next question. Which of the following has the highest neutron ratio? Which of the following has the highest neutron ratio? Yes, that is oxygen 16:8, helium 4:2, then iron, then we have the uranium. Which has the highest neutron ratio? Highest neutron ratio, how we will do? Neutron ratio means here 16 minus 8, mass number minus the atomic number. Yes, correct. It is option D. Nodi. So the highest neutron ratio ಹೇಗೆ calculate ಮಾಡ್ತೀರಾ ಅಂತಂದ್ರೆ, that is neutrons how you will calculate. Mass number ಅಂತಂದ್ರೆ ಏನು? Mass number is the sum of protons and the neutrons here. ಹೌದಾ? Atomic number ಅಂದ್ರೆ only protons ಬರುತ್ತೆ. So ನೀವು mass number ಅನ್ನ protons, number of protons ಅಲ್ಲಿ subtract ಮಾಡಿದ್ರೆ ಅಂದ್ರೆ 16 minus 8, it is 8. 4 minus 2, it is 2. 56 minus 26, it is 20. Yes, so 235 minus 92, like this. If we subtract it, the option D, uranium, is having the highest neutron ratio. Then the next question, when a radioactive substance emits alpha particle, its position in the periodic table is lowered by which of the following? When a radioactive substance, students mute yourself. Yes. So here, when the radioactive substance emits alpha particle, its position in the periodic table is lowered by which of the following? So alpha particle antandre enagatte, that is the mass number decreases by 4 and the atomic number decreases by 2. Adakke ನಾವು alpha particle decay anta ಹೇಳ್ತಾರೆ, ಹೌದಾ? So if that is the case, it will decrease by 1 place, 2 place, 3 place, or the 4 place here. Yes, Rakshita is right. Lohit, Nandish, yes, option B is right. That is, as the atomic number decreases by 2, which means that here the position of the periodic table, in the position of the periodic table, it decreases by 2. Option B is correct here. 2 places. Then the next question, if alpha, beta, gamma rays carry same momentum, which has the longest wavelength? So for this we require, that is, we require lambda is equal to, according to Bohr theory or de Broglie hypothesis, it is H is equal, that is lambda is equal to H upon P. ಏನಂತ ಹೇಳ್ತಿದ್ದಾರೆ ಅದು? alpha, beta, gamma decay do same moment, the momentum is same. So if the momentum is same, which has the longest wavelength? Alpha rays, beta rays, gamma rays, all of the above. Yes. Okay, students, very good. That is option D. All the above. ಯಾಕೆ ಇಲ್ಲಿ ನೋಡಿ, P momentum same ಇದೆ ಅಂತ ಹೇಳ್ತಿದ್ದಾರೆ. The momentum is same. So if the momentum is same, obviously h at least it is a constant. H antu constant ide, p antu enagutte same value irodrinda here it will not affect the what you can say the wavelength also. So all have the same wavelength here. Yes, option D is right. Beta rays emitted from radioactive material are known as electromagnetic radiation. So beta rays emitted by the radioactive material. So radioactive materials will give three types of rays: alpha rays, beta rays, and the gamma rays. So which are, they are known as what? Electromagnetic radiations, whether it is true or no. So everybody agree that it is true? Correct? Yes, it is true. It is a true. So option A is right. Then the next question. If elements with the principal quantum number n is greater than 4, n is greater than 4, were not allowed in nature, then what will be the number of possible elements? Quantum number is greater than 4. Okay, what will be the number of possible element they are asking here? See here, the number of possible elements is 4 only. So we know that the number of electrons given to the atom, it obeys the rule 2n square. How the? It obeys the rule 2n square. Suppose if you substitute n is equal to 1. N is equal to 1 andre 1 square agatte andre 2 electrons you can. Yes, next. Suppose if I substitute n is equal to 2, it is 4. It is 8. Next. It is 18. N is equal to 3. It is 18. Then n is equal to 4. 4 4s are 16. 16 2s are 32. Yes. So total. Now, what is the answer? Yes, Lohit, correct. It is. Yes, option A is right. That is, it is 60. It is 60. Option A is correct. It is. Then the next question. Nucleus, how does its mass vary with volume? For uranium nucleus, how does its mass vary with volume? Yes, students, directly proportional. Yes, correct it is. So what are the options they have given? That is, for uranium nucleus, the mass varies directly, inversely, under root of V, and it is proportional to V square. So option A is correct. Option A. Then our next question. Here some statements they have given. See that. Which of is a correct statement? There is beta rays are the same as the cathode rays. Gamma rays are high energy neutrons. Alpha particles are singly ionized helium atoms. Protons and neutrons have the same mass. Yes. which is right here. C or A. Some are saying it is C, some are saying it as A. See here, the statement which is true, that is beta rays are the same as the cathode rays here. They are same as the cathode rays. Okay, so this is the only sentence which is correct here. Next, which is a non-central force? So the next question is, which is a non-central force? So non-central force ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ನಿಮಗೆ ಅದರದ್ದು ಡೆಫಿನೇಷನ್ ಗೊತ್ತಿರಬೇಕು. That is, for example, if you consider two bodies, so here is one body and here this is the other body. If the force is acting along this center, along the center of the body, this type of forces are called as central forces. These are called as central forces. If the line joining, the force acts along the line joining of the two bodies, it is called as central forces. Question in keltidare, which is non-central force? C. Yes, it is B, nuclear force. It is B, nuclear force. Here the electrostatic force between the charges, gravitational force between the mass, and the spring force, again it is for the mass here, but the nuclear force is a non-central force. It is non-central force as well as it is a charge independent. Then our next question. Okay. Identify the expression for the radius from the following. R is equal to R naught A raised to and cube root of A. R is equal to R naught square root of A. R is equal to R naught A raised to cube. R is equal to R naught A square. Yes. So this we have discussed actually. Synopsis will discuss madidvi. Harshita, mute yourself. Yes, it is A or B. See here, students, the relation is given by what it is. A is equal to, it is A is equal to A naught R raised to 1 by 3. So here, whatever, sorry, R is equal to, not A is equal to. This is R is equal to R naught A raised to 3. R is equal to R naught A raised to 3. So this is the relation between the radius and the mass number. So now you can see the expression. Yaad similar baratte, you can see here. Yes, whether it is option A, B, C, D. Yes, Rakshita, correct. Kumar. Yes, correct. It is Harshita. Very good. So this is option A. R is equal to R naught cube root of A. Option A is correct. Next question. Who measured the size of the nucleus first? Bohr, Einstein, Rutherford, Geiger-Marston. Who will measure the size of the nucleus first? Einstein? Nucleus and Einstein, what is the relation? Yes, it was given by Rutherford. Yes, Lohit, you are right. That is, it was given by Rutherford, students. Rutherford will give the size of the nucleus first. Yes. Option C is correct. Then the next question. Which of the following is a stable nucleus? The nucleus with even protons and odd neutrons. The nucleus with even protons and neutrons. The nucleus with even neutrons and odd protons. Nucleus with odd protons and neutrons. Which one is a stable nucleus? So Kumar is telling it is C. Yes, what about others? Rakshita, Lohit, they are saying it is option B. Harshita. Rupa, Kumar, yes, correct. That is option B, the nucleus with even number of protons and neutrons. Option B is right. Then the next question. A nucleus at rest splits into two nuclear parts having radii in the ratio of 1:3. Find the ratio of their velocities. So we need to calculate the ratio of the velocity here. So Nandish and Deepika is saying it is option B. Let us verify this. Now how you people are getting answer? That is the velocity v1 by v2 is equal to, according to conservation of momentum, that is m1 v1 is equal to m2 v2. How that? Now what I can do, I can just transfer the terms. V1 by v2 is equal to m2 by m1. So the mass value I'll substitute in terms of density. It is becoming 4 by 3 pi r cube into rho density. So if I see this one, 4 by 3 pi and rho, everything is a constant here. Therefore, the mass is directly proportional to r cube anta namge conclusion barutte. Your mass is directly proportional to radius. So now, according to our equation, it is v1 by v2 is equal to m2 by m1. So m2 by m1 in the sense it is 4 by 3 pi r cube into rho divided by 4 by 3 pi r cube into rho. So 4 by 3 pi into r rho will get cancelled. So therefore, what we can write? That is nothing but what? It is r2 by r1 is to the power of 3. R2 is how much? R2 is 3. R1 is 1. So 3 cube. Now you tell me what is the answer. Yes, so it is right. Others? Other students? Correct? That is option D, not C. C baralla, D baratte. Yak heli? So 3 cube is 27. Here it is cube, R cube it is. So 3 cube is 27. 1 cube is 1. Therefore, option D is the appropriate answer here. Okay, next question. Which of the following best define nuclear force? The attraction between protons and neutrons, repulsion between protons and neutrons, the attraction between protons and new electrons, the attraction between protons and electrons, the attraction between electrons and neutrons. Yes, which one is right? Best define nuclear force. Nuclear force ಗೆ ಯಾವುದು appropriate definition ಆಗುತ್ತೆ? A, B, C, D. Yes, Lohit, Rakshita, you people are right. It is C or A, students. See, the nuclear forces within the nucleus it is. So within the nucleus, what we have? Within the nucleus, we have only protons and neutrons. Right? So option A is correct. Option A is correct here. Then our next question. What is the energy released in a nuclear reaction called? So the energy released in the nuclear reaction is called R value, Q value, P value. Then option D, it is nuclear energy. Nuclear energy, no. See, read that part in your textbook. That is the energy released in a nuclear reaction. It is called as Q value. Q value. It is called as Q value. Okay. Not nuclear energy. So confirm that. Then the next question. The nuclear force is a short range force. So postulates alli noಡ್ತೀವಿ ಅಥವಾ properties of the nuclear forces alli we will discuss this. The nuclear force is a short range force. Yes or no? Yes, it is true. It is true. Then the next question. Which of the following is the main result of nuclear fission? Helium, strontium, krypton, barium. Nuclear fission aita. Fission andre splitting up of the nucleus. Fission alli helium baratta athwa krypton baratta, yav baratte? Barium. Yes, krypton. So everybody is giving A, B, C, D, all the answers. So this one you people check it. Which one of the following is the main result of nuclear fission? Actually, ನಾನು ನಿಮ್ಗೆ ಹೇಳಿದ್ದೆ ಮೊದಲೇ fission ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ. So what you do, ನಿಮ್ಮ textbook ಅಲ್ಲಿ fission ಮತ್ತೆ fusion ದ್ದು process ತೋರಿಸಿದ್ದಾರೆ. ಆ example ಅಲ್ಲಿ check ಮಾಡಿ which option they have given. So fusion ಅಲ್ಲಿ ಯಾವ್ದು ಕೊಡ್ತಾರೆ ಪ್ರಾಡಕ್ಟ್ ಅಲ್ಲಿ ಮತ್ತೆ fission ಅಲ್ಲಿ ಯಾವ್ದು ಪ್ರಾಡಕ್ಟ್ ಕೊಡ್ತಾರೆ ಅಂತ ಚೆಕ್ ಮಾಡಿ. Okay, so this question is for your homework. So go through the reaction. Then the next question, uranium-235 mass should be greater than X. Then it is capable of continuous fission by itself. Identify X. It is of the critical size, threshold point, critical shape, specific size. Yes, uranium-235 mass should be greater than X. So it is giving you fission reaction. So if it is giving you fission reaction, whether it is of the critical size or the shape or the specific size or the threshold point. Yes. Akash, Abhishek, Deepika, Harshita, what is the answer? Threshold. It is there in your book. So illodi, for example, nuclear fission reaction agbekadre we require the heavy nucleus. Hauda? So greater than uranium anta heltidare andre obviously adu yavdide heavy nucleus only it is. Therefore yes, that is it should be of the critical size. Then our next question. Which of the following forms the basis of a nuclear reactor? Uncontrolled chain reaction, fast nuclear reaction, controlled chain reaction, catalyst controlled nuclear reaction. Which one is right? C and D both. Then which catalyst they are using there? So the nuclear reactor nuclear reactors uncontrolled chain reaction agatte alli. Nuclear reactor, the uncontrolled chain reaction takes place. Catalyst controlled nuclear reaction. Yes. Catalyst controlled, but catalyst anta allen use madala. Actually, they are using their rods. So the rods are used, therefore the controlled chain reaction only we can say that. They can control that chain reaction. So catalyst controlled reaction. Okay, we can go for option D. Option D tagolana, no problem. Option D is right here. Okay, then next. Controlled chain reactions form the basis of an atomic bomb. Yes, it is true or no? It is false. It is false. So atomic bomb it is uncontrolled reaction. It is uncontrolled reaction. Correct. Okay. Then the next question. So another 3-4 questions we will see. Then we will go for the previous year questions. Okay. The question is, why is a fusion reaction difficult to perform? Why? Why is a fusion reaction difficult to perform? So options are, the nuclei are set up far from each other. The attraction between the nuclei, the sun's energy is not sufficient, repulsion between the nuclei. Yes. Okay, here actually the repulsion between the nuclei, that is right. But instead of this, in the question, or enadru illi high energy is required anta kottidre ನಾವು ಅದನ್ನ ತಗೋಬಹುದಾಗಿತ್ತು, but ಅಲ್ಲಿ energy related ಏನು options ಅಲ್ಲಿ ಇಲ್ಲ. Therefore it is right. The repulsion between the nuclei is high. Therefore ಏನಾಗುತ್ತೆ, fusion reaction ಗೆ difficult ಆಗುತ್ತೆ. But if you give the sufficient very high temperature, then it is possible. Otherwise it will be difficult. Yes. Now, what is the energy released in the fission of 2 kg of uranium 235? The energy per fission is 200 mega electron volt. We need to calculate the energy. Energy calculate madbekagide. Yes. So what is the energy released in the fission of 2 kg of uranium 235? Yes. How to do this? So who got the answer? They are saying it is option C. Let us confirm whether it is C, true or no. Everybody is getting C. Okay, so may all are getting the option C, but to once just we will see the solution part, how to do this. So here the energy required, or the energy is how much they are saying, 200 mega electron volt. Yes, so convert it in terms of joules. 200 into 10 raised to 6 into 1.6 into 10 raised to minus 19. Okay, so if we do this conversion, it is 3.2 into 10 raised to minus 11 joules. How the number of atoms in 1 kg? But they are asking here for 2 kg. So 2 kg in the sense it is 2000 into the Avogadro numbers 6.023 into 10 raised to 23 divided by it is uranium 235 nucleus, therefore it is divided by 235. So here if you simplify, check what answer you are getting. then the total energy released will be here, whatever the answer you are getting, that is multiplied by 3.2 into 10 raised to minus 11. Ide method A barata, C barata. Some are getting A, some are getting C. ನೀವು ಇದನ್ನೇ ಫಾರ್ಮುಲಾ ಯೂಸ್ ಮಾಡಿದೀರಾ ಅಂತ ಅನ್ಕೊಂತೀನಿ. The energy is 200 electron. It is electron volt, convert it in terms of joules. ಎಷ್ಟಾಗುತ್ತೆ 3.2 into 10 raised to minus 11 ಅಂತ ಆಗುತ್ತೆ. Right? The energy released for 2 kg of uranium-235, it is given by 2000 into the Avogadro number upon 235 uranium. ಹೌದಾ? So simplify that, multiply it with 3.2 into 10 raised to minus 11. ಎಷ್ಟು ಬರುತ್ತೆ? C. Yes, I'll take the answer C. Okay, so the correct option is option C. Option C is right. That is 2.64 into 10 raised to minus 11. So one more last question. After that, previous year questions we will see. Radioactive material decays by simultaneous emission of two particles with respective half-lives 1620, that is 1620 and 810 years. The time in years after which 1/4 of the material remains. So here half-life period, it is related to half-life period. How we are going to simplify this? So the question is what the radioactive material is of particles with the half-life 1620 and 810 years. Yes, let us simplify this one. So Chandana is saying option B we will get. Let us see. Again, who got the answer? Asha is saying B. So let us try this one. The total T half is given by, the total of T half is given by 1620. It is 1620 into 810 divided by 1620 plus 810. So this will be total of 540 years. This will be total of 540 years. Okay. So according to radioactivity differentiation, K is equal to the constant. K is constant here. It is given by ln of 2 divided by 540. Okay. So what is that equation? It is given by n is equal to n0 into e raised to minus kt. Right? And here it is given that your n value is decreasing by 1/4 value. Therefore, we can substitute n is equal to, n is equal to n0 upon 4. It is given by n0 upon 4. Yes. So substitute n is equal to n0 upon 4. n0 will get cancelled. Therefore, I'll get here only e to the power kt is equal to 4. Therefore, kt is equal to, it is 2 ln 2. So therefore T is equal to, so simplify this, check how much you are getting. Option A or which one it is? Yes, correct. Harshita, Lohit, yes, option A is right. That is 1080. Option A is correct. Okay. Okay, till now you can do this question. Next I'll tell you the previous year questions. Which of the following substances cannot be emitted by radioactive substances during their decay? Okay, you just tell me the answer. I'll tell you the previous year questions now. Protons, both A and B. Radioactive substance. So radioactive decay process alli nodi, you have already alpha, beta, gamma decays. In that process you check yaud baralla nodi, protons baralvo, neutrons, helium. It is not neutrons actually, neutrons anta ide. Correct student. Protons, neutrons will be released. Aita option A. So let us go for previous year question. Just some 2 questions we'll discuss. Other questions nimge sir forward ಮಾಡ್ತಾರೆ ಆಯ್ತಾ ಆಮೇಲೆ. I have already given, he will send you. The question is, I think already the one question now discuss ಮಾಡಿದ್ವಿ ನೋಡಿ, that is the nucleoside rest splits into two nuclear parts. It will split into 2 parts. The nucleus is split into 2 parts having the radii 1:2. Having the radii 1:2. What are the velocity ratios? Velocity ratio ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು. Radii ratio ಎಷ್ಟಿದೆ? 1:2 ಇದೆ. What is the velocity ratio? It is 2015 Karnataka CET. Velocity ratio. Second question ಅಲ್ಲಿ ನಾವು ಈ ತರ ಕ್ವೆಶ್ಚನ್ ಮಾಡಿದ್ವಿ ಈಗಷ್ಟೇ. ಯಾವ್ದು ಬರುತ್ತೆ? Radii is of the ratio of 1:2. The velocity ratio. Yes, Lohit is saying 8:1. Yes, so the options are given as it is 4:1, 8:1, then 2:1, and 6:1. Yes, option B is right. That is 8:1. Correct. Okay. Correct agide. Then the one more question that is asked in 2016 Karnataka CET. The question is, an element X decays into element Z. X will decay into element Z by 2 steps process. Okay, ಇಲ್ಲಿ ಏನಾಗ್ತಾ ಇದೆ, X ಇದ್ದದ್ದು Z ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಎಷ್ಟು process ಅಲ್ಲಿ? 2 steps ಅಲ್ಲಿ. ಒಂದರಲ್ಲಿ ಏನಾಗುತ್ತೆ, X is getting converted to Y plus it is giving out helium. Then later the Y is getting converted to Z with 2 electrons. Then so the options are X and Z are isobars. X and Z are isobars. The next, X and Y are isotopes. X and Y are isotopes. X and Z are isotones. Then X and Z are isotopes. Yes, which one is right? Question ಅರ್ಥ ಆಯ್ತಾ? Question ಮತ್ತೆ options ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೂ? So X ಇದ್ದದ್ದು Z ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗ್ತಾ ಇದೆ 2 steps ಅಲ್ಲಿ. The reaction is given here. ಇಲ್ಲಿ X ಮತ್ತೆ Z ಅಥವಾ Y ದ ರಿಲೇಶನ್ ಏನಿದೆ ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ ಅವರು. X and Z are isobars, X and Y are isotopes, X and Z are isotones, X and Z are isotopes. ಯಾವ್ದು ಕರೆಕ್ಟ್ ಆಗುತ್ತೆ? Question is clear? Is it clear? Question A or D? It is D, students. It is D. D is right here. It is X and Z are isotopes. X ಮತ್ತೆ Z ಏನಿದೆ ಇಲ್ಲಿ isotopes ಆಗಿದೆ. Okay, yes. So I think from 2014 to 2019 all the questions I have given to sir. So he will share you later. This is atoms and nuclei. Matte ray optics matte wave optics. So till evening I'll make sure that it will reach you. Okay, thank you. Have a good day, students. Next week we will meet.
Thank you, ma'am.
Yes, thank you.